to more viewers. Those viewers can join this growing community and post tips and tricks, or they can post requests, which I will personally review and then I'll share with everyone. Now, with that said, on to the show. And the intro is save RAM with the tiny autoencoder, or TAESD. Just a little quick background for this. It's because when I got into AI, especially like really got serious about it last year, I was just basically doing a copy pasta, meaning I'll just copy stuff I found on the internet and just try it out. And it was very slow, so I was thinking, oh, what's wrong? I upgraded my system, especially when I upgraded my system, thinking, why is it so much slower? That is because I didn't understand most of these things. However, I've repeated this even I think yesterday, is that one of my viewers, when I did one of my first night stream, it's not the first one, really helped me understand what GPU and memory and all that, and then what to get. And then later on, when I actually upgraded my system, another viewer helped me. I just went through like 3-4 hours like on a live stream, which is crazy. So anyways, the point is that I do understand all that stuff now, and that's why I said that before. I'll share my knowledge with you. Now, I didn't realize I was on the home page here, so basically just go to watch menu, and you can see here it says accelerating WAN models with the TAESD and custom encoders. So what this means is that, for example, my particular system, I have 32 gigs of RAM, yes, 32 gigs of RAM, and I have a 32 gigs of VRAM for the dedicated graphics card. Now, let's go back to that RAM. I don't get to use all of it because I also have an integrated graphics. The integrated graphics reserves 4 gigs of that. So that means I only have 28 gigs of RAM, but that's also not quite correct, because I'll give an example. Right now, I'm running OBS. I'm running a whole bunch of browsers. I have other applications running in the background. So clearly, I don't really get the 28. And before, I was also running ZRAM. So it's more like 21, 22 of usable RAM. But even then, you don't want to use all of it up. You need to leave a little, wiggle room for yourself. So what that means, what I'm trying to say is that I'm restricted with RAM, even though I have a pretty good graphics card. I'm limited for RAM. So what I have to do is I always have to find ways to optimize my particular setup. I'm not going to blow money on RAM or more bigger storage until the prices go back to. I'm not going to get ripped off. I refuse to get ripped off. If someone wants to donate some hardware to me, fantastic. I'll give you credit and everything, but I'm not going to blow the money on it. All right. So the good news is, when I do this research, I'm able to share with you guys. So meaning that whether you only have a laptop, you don't have a dedicated GPU, you're restricted to RAM, or your GPU as well. So this research I do benefits more people, and it's actually pretty good, because from what I read, the RAM prices were supposed to stay up until the end of 2026, but it looks like it's actually been extended now to 2028, because the US government is going to basically bail out all the AI companies, especially the very large ones. So that means they will keep on buying at obscene rates the prices also for the RAM and storage. So that's unfortunate for the rest of us. However, so what I'm going to show you today is to prove to you that by using a tiny autoencoder, we're able to use the WAN models. By the way, if you don't know, Wan 2.1 and Wan 2.2, those are open source models to generate video. So as you guys know, video is probably one of the hardest things for your local AI to perform. Because it's restricted on our, the consumer grade systems. We're restricted with the amount of RAM we can have, and obviously the GPU VRAM. So getting this to run is actually pretty impressive. All right. So what I'm going to use is I'm going to use an application called stable-diffusion.cpp. And that one is great because you don't have to install a whole bunch of Python packages. Especially, I said, for me, this works very well because I'm restricted. Also, I said I haven't been able to upgrade my storage space, so I'm really. I'll show you my system specs. So Now, the good thing about the stable diffusion CPP, you can even compile it yourself. It doesn't take long to compile. So, for example, if you want to run a Vulkan or just a CPU, I wouldn't recommend just running this. If you're going to run CPU, at least use OpenBlast. That will speed things up tremendously. But you can run Vulkan, you can OpenCL, you can run it on Metal if you're Mac OS, obviously NVIDIA, CUDA, and if you have AMD, which I do, Rock M. And if your GPU is no longer officially supported, you said you can use Vulkan as well. Okay, so you also so the models that I do have, I have the Wan 2.1, 1.3B model. The reason I like this 1.3B model because it's very small and it should fit basically on most hardware today, whether it's integrated graphics or dedicated graphics. It's very, very small. It's 1.3 billion parameters. It's very, very small. Usually it's about a 1 gig, even the GGF versions. So it should run fast, decently enough. And then the Wan 2.2, I did try to get some decent results with the 5B model, but I was not. So I decided just to go to the 14B. The 14B just blew me away. I've explained this before. It just blew my mind. So I stick with the 2.2 14B. It's vastly superior to 5B, and most of the ones you get, especially the quantized or distilled, they're like 4 steps. So meaning that it's actually going to run faster than the 5B model. So that's fantastic. And the great thing about this is that it uses the same VAE. So meaning that if I get a text encoder for the 2.1, it also works with the 2.2 14B. So that makes it really, really amazing. So the great thing about the tiny encoder files, they're much smaller than VAEs. So what that means is that they'll run much faster. Obviously, they make some assumptions. So there could be some artifacts because it's not full, but I'm saying that maybe you want to do a quick prototype, definitely use the tiny autoencoder. And then obviously the 1.3B model, as I said before, it works well on laptops, for example. The 40B requires more video memory or more RAM as well. So one of the things I dislike is when I go research and I try to find research on low RAM, I can't find anything. The things that comes up, people saying, oh, you can run this on low VRAM. The problem is I've seen those setups. The people who have low VRAM, they might say, okay, look, this can run on an 8 gig GPU or 16 gig GPU. I'm like, that's considered low? Okay. And then they have like 256 gigabytes of RAM. So I'm thinking, that's not really what I want, because obviously, I have, as I said, I have low RAM. So I'm like in a unique position. So, and then the other thing is also replace the text encoder. So the regular T5 encoder is very large. You can replace it with a smaller version. You can use the quantized GGF versions of the T5. This fits much better with into the system RAM as well. And then you can use the VAE flag for the standard autoencoder and use the TAESD flag for the fast tiny autoencoder. So the command line tool accepts separate text encoder paths. Point your software to the downloaded encoder. You can combine the tiny autoencoder with small encoder, saves memory. This allows 14B models to run locally, and I'll show you that as well. And here, as you can see the screenshot, this is the 1.3B, 1.3, and this is the one with this is autoencoder. What did I do here? Oh no, sorry. This is the Q4, and you can see it's missing some details. And then with the Q8 one, it has more detail here. For some reason, when I did the article, I updated the stable diffusion C++, and then it refused to generate anything for the Wan 2.2. So I tried different things, it would not. I even tried the original text encoder and the VAE, just completely refused. So I was like, okay, whatever, maybe there'll be an update. I think because there was an update in GGML, so hopefully this has been fixed and it'll work today. Yeah, because I even tried the binaries. And then here I'm trying it with the tiny auto encoder. You can see there's no problem with the video here. and then I tried also with the the tiny encoder, the Q4, and then the tiny encoder, the Q8. So I also tried the tiny encoder, the 14B. I can't run the Q8 because I don't have enough, as I said, enough RAM, so I just stick to the Q4. I wasn't able to produce something here. Hopefully today we'll produce something. Okay, and that's about it. All right, now before we begin, I'm going to show you some links just so that you understand. So I have made some tutorials. Actually, when I was explaining what a tiny autoencoder is, I explained why I use Fedora Linux. So I'm not going to go through it again. It just came out, well, today is Sunday, so I guess it's a new week, but just came out last week, just a few days ago. If you can go check, or you can check here on jambo.com. Just search for TAESD or tiny autoencoder, it will come up. And let me actually do it. Let me open up a new tab here. If I just go to the home page, which I am here, it should be, I just talked about it. Here we go. See, it's the introduction to TAESD. So this is the one this was just a talk, so podcast. You can see I explained what it does, the quality and trade-offs. So so there's a video for this as well. So as I said, it's just a few days ago I explained what a tiny autoencoder is. Today we're actually going to use it. So I just want to let you know. You can pick that up if you wish. Now, there's also a GitHub page for the tiny autoencoder. So we'll take a look at that. You see the tiny autoencoder for stable diffusion and other image models. So what is a TAESD? It's a very tiny autoencoder which uses the same latent API as the stable diffusion VAE. TAESD can decode stable diffusion latents into full-size images at nearly zero cost. Here's a comparison on the person's laptop, the developer's laptop. As you can see, it looks pretty good to me. I can't really see any difference. And here's another one. It says it's compatible with SDXL models using the TAESDLXL and the weights, and SD3 obviously using the TAESD3, and several non-SD models have support too, so that's why I'll explain that later. And you can see here you can use it for Flux 1, Flux 2, Quen image, Sana, and it's also available for automatic 1.1.1, and then Valmatic, Comfy UI. And then you see here, these are the ones we have just quickly talked about. But wait, there's more. I'll explain that in a second. So what it can be used for, as you can see here, how does it work? It's a tiny distilled version of stable diffusion VAE, which consists of an encoder and a decoder. So the encoder turns full-size images into small latent ones with a 48 times lossy compression, and the decoder then generates the new full-size images based on the encoded latents, making up the new details. So it does have some limitations, as here's an example. So as I said, there will be a modest loss in quality for substantial gain in speed and convenience. So that's what I'm looking for. Remember I told you there's also more. There's more. Here is where we come in. You see, it does work with video generators. As you can see here, stable diffusion or animate LCM, and it details new details for each frame. So the results will flicker a bit, but it should work. You can see here there's this one TAEHV. This is for Wan video, and you can see here Wan video 1.5, Wan 2.1, Wan 2.2. This is the one today's tutorial what we're going to focus on. Quen image, Cog video X, Open Sora 1.3, and LTX2. Oh, I didn't know it's LTX2. I think that's amazing. And then I already talked about the stable diffusion 1, 2, and the stable diffusion video, and then this one for Mochi 1. So as you can see here, the comparison table is here as well. So I wanted to show you that. And then there's also a dedicated page by Leejet for the stable diffusion C++. Oops, looks like that went away. Looks like it changed. Okay, so we'll have to go find it out. No big deal. So we'll come back to it in a second. I don't know what happened to it. So this is stable diffusion C++. This is what we're gonna do. We're gonna take care of today. And you see stable diffusion CPP or C++. Okay, I don't know why this always comes up to that screen. And you can see the added support for Flux 2 client, which I did a tutorial on this. See, it does support, the usual image models. Today we're focusing on the video models, Wan 2.1 and Wan 2.2, and you see the supported backends here. CPU, CUDA, as I said, Vulkan, Metal, OpenCL, and this one is I think the Wan API by Intel. Yes, it is. And you can see it supports PyTorch, Checkpoint, Safe Tensors, and GGUF. And then it's multiple Linux, Mac OS, Windows, Android via Atomics. This is the one for OpenCL and the sampling. It doesn't have everything configured as, but it's getting there. The good thing is there's no Python involved, which is fantastic. So this is the build guide here. I'll show you that in a second. And you can see here, you can quantize the GGF. What are the... So the one I'm more interested in is this one here, TAESD for faster decoding. Open up in a new and here the latest release came out just yesterday, so I'll grab that one. So if we just go there, you can see you guys, if you're on Windows, you're pretty lucky because basically they have Vulkan, RockM, CUDA, and a bunch of they have Vulkan. I think the only one they probably don't have is Vulkan, but they do have what do you call them, CPU, pretty straightforward. And for Linux, you have the Vulkan one and you have the CPU only. And then for Mac OS, as I said, you have the Darwin. So this came out literally at the time of this recording. This just came out yesterday, so I will be able to update it. And here, this is the build instructions. So basically just clone it, and then you also make sure you pull in the sub modules, especially if you're doing an update. That's what I'm going to do. You can see you can build for CPU. I don't recommend building for CPU only. I will highly recommend using OpenBlast. That will speed you up the CPU stuff. Or use this and all Vulkan. And CUDA, of course, for NVIDIA GPUs, HE+. This is for AMD, RockM. That's the one I'm going to build. There's Musa for the Moore threads. Metal for the Darwin, I was going to say iOS, Mac. Vulkan is cross-platform. It works everywhere, so you can use this. Vulkan, I really have high hopes for Vulkan because, especially if your GPU is no longer supported or you have a very old CPU, with Vulkan, that'll be fantastic. It actually loads much faster. There are some cases, there have been tests online where Vulkan is actually faster than RockM. So I said really, and that's so Vulkan is Vulkan is definitely the future. Hopefully, especially when you test video and stuff. And then OpenCL, I said, for the Arduino GPU. And then down here we have this one I was right about. This is the Intel GPU. All right. So, and then close. Here we go. The TAESD for faster decoding. So you can use TSD to do accelerated decoding learning. I already explained this. And you see for the Quen image and Wan, TAEHV. So this is the ones we use. You see for the Wan. So I don't have this one anymore. So I don't do the 5B model 2.2, but I do have Wan 2.1 and Wan 2.2 A4B. It works. So that's what we're gonna use. And basically just replace VAE with TAE. That is all. And if you run out of RAM, you just use this VAE convert direct. Okay, anything else I need to show you guys? I think that's about it. Oh yeah. So and I got my I downloaded all my model and weights from Hugging Face. So I'm going to show that to you guys now. Right. So you can just do a search and yeah, you can go. So this is Wan 2.1. So this is where I got the. Here we go. I think split files. Yeah, split files, division models. yeah, you see the B models. I just downloaded Wan 2.1, 2.1, 1.3b. One of these ones. You see, I didn't get the. I can probably get this, the FP16, that fits perfectly in my GPU, but I got the quantized version. But you can get it there. And if you want the GGUF versions, again, I got all this stuff from Hugging Face. So you see here, you can get, I don't recommend getting a 2-bit or 3-bit, get at least a 4-bit. You see, they're pretty small. They're around just, you see, like the Q4 one is only, it's just under a gig. So you can get some of these ones here and they work perfectly fine. And I said I also got 8-bit. Obviously, I can also run the FP16 one here. But I did grab, that's where I grabbed them from. It's Celsius. Okay, and also if you want the distilled version, which I got for the Wan 2.2 image to video, I grabbed this one. I got this distilled light X2. This one I do use in ComfyUI. You can see I can't get the 8-bit, so it has low noise and high noise. So as you can see, the problem here why I didn't get the 8-bit version is because it's a 15.4. So if I get both of them, they won't fit in my GPU. So I could probably get away with the 6-bit, but I did get the I think I got this one, yeah, K4M. These ones did work, so those are ones I do use. Now for the text encoder, you can also get GGF versions. That's the one I use. You can see you have 3-bit, 4-bit. I don't recommend getting a 3-bit here. Get at least a 4-bit. I grabbed this one, K4M. I can also grab this one, which is a 8 one. It's 6 gigs. So this is the one that I can use. Now, for the piece de resistance, the tiny auto encoder, I got the GGF versions as well from Runware. Okay, so you see here, this is the one, TAEW2, obviously 2.1, and you can see the size, 22.7 megabytes, much smaller than VAEs. You see that? So it's much smaller. So that's what I did. Now, where do I put all these files? So let me show you. In order not to waste any time, what I did is I obviously started up my, because my GPU, it's an AMD Instinct MI60, it doesn't come with any cooling apparatus. So what I did was I got a 3D printed fan shroud and a 40 millimeter fan, so it blows it right through. That's how it cools it. Right now it's basically on idle, so it's just under 3000 RPMs. So I'll set this up to about 35, 45 for when we start. So this is what I'm running this app image. So let's go to ComfyUI, and yes, I do share the models between ComfyUI and obviously stable-diffusion. So the first thing we're going to do is we're going to go to let's go to our, where is it here? Text encoders. You see the text encoders? I'm going to use this one. I have this one, Quen 3.4b Instruct 2507. It's Q8. You see it's 4.3 gigs. And then remember, I promised you guys I would also have this one, the 4K, this extra large. It's 2.5 gigs. And then we have this one here. This one is 3.7. And then this one here is 6 gigs. And then we go to VAE here. You can see this, so you can compare. This is the 2.1 VAE safe tensors. It's 260 megabytes. And remember, this tiny autoencoder is 22. So obviously you can tell there's going to be a massive performance difference there compared to this regular one, which is also 335. This is for the Z Image Turbo. This one I don't remember what it was for. I don't even think I use this anymore. I'll probably get rid of. Oh yeah, I think I can replace this this one for the Z Image Turbo, because this one is FP32 and 16, which is better aligned for my GPU. Alright, then we go to the unit folder. Where's unit? Here's unit folder. As you can see, I do have the one, it's exactly 1 gig. Wan 2.1 text to video 1.3 Q4 KM. I also have the Wan 2.1 text to video 1.3 Q8. It's 1.6 gigs. And you can see here I do have this high noise, but I'm not going to use high noise today. I'm just going to focus on the low noise one here. The Wan 2.2, this is a low noise. It's a light image to video. It's 4 steps. I also got this all-in-one. This one is a Q4. You see it's 11 gigs. And then I also got, I think this is for, what are two of them? Oh, this is a Q4, and this is the Q8 version, and then I have the Z image turbo as well. The K4M and the Q8. So that's all I wanted to show you guys. Now let's go back to the AI folder. We go to the stable diffusion folder here, and then we go to the build folder here. So as you can see, I did generate some. Oh, did I delete them? Oh, I deleted the videos. Hopefully things don't mess up here. So I'm going to leave this. I'm going to take it out here for now. Make it a little bit smaller. And then I'm going to put this in here so people who are on a vertical screen should be able to see properly as well. Alright. So the first thing I'm going to do is, where am I? Oh, I think I need to put stable diffusion. Yeah, stable diffusion. So I'm in the stable diffusion folder. I'm going to do a git pull. So it's gonna, yeah, you see there's some changes. I'm gonna zoom out just a little bit. Where is my mouse? So you see I did, there's 4 files which I've changed. There's 383 insertions and 13 deletions. So I was basically behind only one commit behind. But that's, oh no, that's not true. 1, 2, 3. I was about 4 commits behind, so that's perfectly fine. Now I'm not quite up to date because I also need to pull in the sub module, which is ggml. Last time there was actually an update. Let's see if there's an update this time. Okay, there's nothing. That's what I expected. So you just cd to your build folder, and these commands were in the from the website I showed you. Let me actually clear this. I'm going to zoom out just a little bit more. So this means that I have ROCm installed. And it's going to find my GPU, of course. It's a GFX 906 or AMD Instinct MI60. Then I'm going to do a CMake. You see here, I disable Vulkan, although I have Vulkan installed because I don't need Vulkan. Yeah, and so I'm perfectly fine with this. And then I'm going to do a build and release, and you see how long it takes. As you can see here, the ggml version is 0.95. Okay, so this should be hopefully faster. It's pretty. Oh wow, there's actually way more warnings this time than last time. Okay. It's done, you see? So it's finished, completely finished. So it's finished, so I'm gonna clear this and we can start generating some videos now. So the first thing is, I'm assuming you guys already downloaded those models I showed you. So I need to, I'm gonna set this to 35 for now, the fan. Okay, so the first thing we're going to do is we're going to generate a video using Q4M and Wan 2.1 1.3b. So I'll show you what I put in my command prompt. So as you can see here, I'm using stable-diffusion, video generation. Diffusion model, you see the path is the conf UI because I said I do share this with conf UI, and you see I'm using the quantized Q4 4km. M stands for medium, so 4 is usually a good medium in there. The VAE, I'm using an actual VAE file. I know you guys are saying, wait a minute, you said you're going to use the text, you're going to use the tiny encoder. Yes, I will. I'm just comparing to see how long this takes and everything. And then the actual, what is this one here? That's a VAE. You see I'm using the safe dancers. And then the text encoder, you see I'm also using a Q4KM as well. And then the prompt is a lovely cut. And this CFG scale is set to 6. Sampling method is Euler. And I put verbose on, and the negative prompt, this is in I think it's simplified Chinese. It basically means that, you know, don't make extra arms, all that stuff. And then the width is 832, the height is 480, so meaning it's going to be landscape. It's one of the natural what do you call it, the natural resolution that the model is trained on. The video frames are 33, flow shift is set to 3.0, VAE tiling is set on, cache mode is set to easy cache, cache preset is ultra. What this means is that it will keep everything in the VRAM. So I'm able to do this because it's a very small model. And diffusion convert direct, and the VAE convert direct, and VO tile size 128 by 128, and then you see the type is Q4K, and the output here. Now let's go down and see what this guy is up to. So you see it's a little bit slow loading. You see it's about 21 seconds per iteration because it's going to run the 20 steps. So yeah, so it is slow. It is slow, but the quality will be okay. And this is the reason I said I wanted to use the Wan 2.25B. But the 14B is much faster, and as you guys will see later. So we'll let this guy run. You can see it doesn't take up too much. Everything is right now it's using just under 10 gigs of VRAM. Everything will fit in there. Now some of you might say, why aren't you using flash attention? That doesn't work on this GPU. Okay, or some other things. So that's why I'm saying that make sure you know your GPU. Otherwise you'll just be waiting and waiting and waiting for a very long time. Okay, I'm gonna grab a little glass of water. Whew, boy is it cold today. I'm so glad my neighbor helped me with the clearing the driveway yesterday because it was so cold. I put it off until today. Right now I think, yeah, when I went out in the morning it was like minus 19 degrees Celsius, so it was still very cold. Not as cold as yesterday, but it's still pretty cold. And right now it's calm. I think right now it might be maybe in minus 15 degrees, so much better. I could actually go outside right now, but I don't want to. The chickens will be fine. I think today is the coldest day, the last of the coldest days of winter, at least for February. I don't think it'll be cold in March. And the weird thing is, so far this month, we're only on today is the 8th, February the 8th. This month, February, there's been way more sun days than all of fall and winter so far, which is really strange. And the sun days are actually longer. What I mean is that the sun is out way longer than... I do remember on October 15th, I was inside the hoop coop. I went to pick up eggs and clean up, and I couldn't see anything. It was pitch dark, like black. I couldn't see anything. So I had to give up the eggs. That's why I started going in the morning. Normally what I would do, I would go in the morning, and then I'll go in the after this live stream. But yeah, looks like probably by the end of this month I can start going back again morning and the afternoon. So the girls will be happy, especially when it finally stops snowing. So as you can see here, when you use easy cache, it's skipped. You see here, it only did 11 out of the 20 steps. So that's one of the reasons I use the easy cache. You didn't have to go through all the entire, especially since how slow it was. But you can see it sped it up at the end because it skipped, is it 9? Yeah, no, sorry, 11. It skipped 11 of the 20 steps. And it's done. So according to this, it took 263 seconds. What is that, 4 minutes? just under 4 minutes, and here is the result. Here's the result right here. So I'm gonna play. Actually, you know what? Before I play it, I'm gonna start the next prompt, and then I can play this video. So I'm gonna run the next prompt. Let me clear this. I'm gonna run this next prompt, so I don't have to wait around. The prompt is exactly the same, except this time I'm using the Q8 model. All right. So then what I'll do is I'll go and play this video here. I'll double click on it. Hopefully, yeah, there we go. So you see it's just over 2 seconds, and you see not bad. So if people on a vertical screen and they still can't see it, there we go. See, not bad at all. It has that Wan 2.1, especially 1.3b, just like little jerky thing, but it's perfectly fine for 2 seconds. All right. So I'm glad that worked, because last time I tried to use this model, especially when I was writing the article, it gave me some problems, and hopefully all those are resolved, and I can run it without problems today. So you see right now we're running the 1.3b, and this one should hopefully skip some steps as well, because I did this before. So I'm also using the easy cache and all that, and it's small enough that it should also fit onto the GPU. Excuse me. So right now it's one step. So it finished one step, is in the second step. It should also skip some of those steps, because it's also using what do you call it? It's also using the the same easy cache. So it will speed up at the end. I expect it to be just a little bit slower than the Q4 model. But yeah, definitely, as you saw, there's no Python to use here. It's just a C++, and it works really, really well. I didn't even check the temperature. Okay, so one trick I also found out is, you see the temperature here for the GPU. Where is my mouse? You see the temperature is 82. That's kind of a little bit high. So what I'm going to do, I'm running 35%. I'm going to bump it up to 45%. What happens is once it gets around 80, in the high 80s, it does throttle. So I don't want that. So I will, you know what? I'll put it at 55. Put it at 55. Put it at 55 because I don't want to be throttled. So hopefully it will give us, it'll go a little bit better. Yeah, I'm more comfortable there. 81 is okay. Right now it's fourth step. You see it jumped. It jumped from 4 to 7, so it's skipping some steps. And yeah, so hopefully okay, according to the chat, I get the same I might have to block chat on Kick, because I get the same spammers. Let's promote your channel, let's promote your channel. Why don't you clear them? See if I can clear that. Okay, there you go. It's most likely a bot. Alright, so it looks like it probably skipped a few more steps. Now it's at 15. About 13.15 seconds per iteration. That's actually pretty good. And the compute buffer size. So this is what people don't understand. See, this compute buffer size is basically just under 10 gigs. So that's what I was trying to say, is that if I can keep everything, oh, it's 15. Skip some more steps. If I can keep everything in the VRAM, I'll be much more happier than trying to run RAM because it's slower than VRAM, and then obviously on the storage device, which is even slower. So as you can see here now, it's at 19 out of 20. So clearly it skipped even more steps. Because remember, it started out about 24 seconds per iteration, and then now it's 11.82 seconds. So there we go. How many steps did it skip this time? It skipped, it skipped 11 out of 20 steps. And yeah, the VA tile size on 4x60. So there's a little performance hit if you use tiling, but what I found is that it's actually pretty good, especially when you're trying to make slightly higher resolution images. It does a pretty good job. Now look how much the buffer size increased by. You see this? It's 20 gigs, right? So that's what I was trying to say, is that quantization, GGF, all that stuff is good, but you have to be careful as well, because you get things like this. Now the video came out well. So what I'm going to do is, before I play that video, I'm going to start the third prompt. And it didn't work for me last time. Hopefully it does work when I create the article. Hopefully it works today. It was producing black images, and I don't know why, because it was working prior. So this is you see this one here, it says Q8. This is the one that was just produced with the Q8 version of the Wan 2.1 1.3b. Let's play that one. You see, it's a slightly better quality, right? It's slightly more realistic. I don't know, it likes putting a lot of blur stuff, but yeah. So there we go. That's a Q8 version. Let's play them both together, so you can see the difference. The prompt is exactly the same. It's a lovely cut. So there we go. So this is the Q4, and this is the Q8. If you actually look here, right here as well, you can see, yeah, so the Q8 is obviously way better, but I'm saying is overall, both the results are not too shabby. Not as good, as I said, as the Wan 2.2 14b, but not too bad at all. Not too bad at all. Okay, so I'll stop both of them. Put this guy here. If this one produces a black image, I'll just skip it. I won't run it with the tiny auto encoder. See, one of the good things about the Wan 2.2, you see, even though it's a much larger model, look how fast it is. It's going just for loading. Oh, is that slow? Oh yeah, no, that's actually that number should be bigger. Sorry, yeah, that's a little bit slow. It should be bigger. That could be OBS. Alright, so if you join the live chat right now, your chat posting will show up somewhere around here. Where's that loading? It's loading the text encoder now. Temperature is at 74. Take another sip of water. So weird, the water smells like beans for some reason. Okay, so I didn't show you the command I ran for the sorry, I apologize about that. You can see how much space it uses. It's using 15. So yeah, it's giving me an error. So it gave me an error. So I'm not able to run. Yeah, so it gave me an error. So I'll show you what command I did run for the Wan 2. Come on. Oh wow. Where is it here? Okay, here's the command I ran. Obviously, you see I'm using Wan 2.2. I'm using the low noise. the 4-step one, and because it's 4 steps, you see I changed the CFG scale to 1.0, and I had to, I also put everything else I think stays the same. I already tried a whole bunch of different things. I haven't tried putting steps at 4. It still just doesn't produce anything. You see I even gave it an initial image. I also made the image 832 by 480. I tried a whole bunch of stuff and it just refuses to work. It did work before, prior to an update, but I don't feel like, okay, so I'm gonna clear this. Oh, it's still running, so let me Control C. I know it's still running because it just crashed, so it needs to release this, so hopefully it will release it. So while it's doing that, I'll show you the system monitor. You can see it's still using some of my RAM because it's 16 gigs here. It's using some of the swaps, so I need it to clear. So I'll give it a few minutes. If it doesn't, I will actually. And so here's my system, Ryzen 5 600 GT. So you see, it's still not. It hasn't released everything yet. So what I'm going to do is I'm going to put this guy here for those people who want to see what's going on. Why can I make this smaller? Okay, that's good enough. It still hasn't. You see, it still hasn't. It released some memory, but there's still a lot of it in swap. So there's a ways I can kill this. Let me try it again. So I'm gonna. I don't want to wait because this tutorial will take too long. But yeah, it definitely did crash. So what I'll do is I'll open up a new tab because the other model is pretty small. So that's what I'm gonna focus on. Goodness. Okay, I think I might have to kill this. I'll just kill it. Close. Oh, it's still running. Wow. Okay, it's not releasing it. I'm not sure. Okay, I'm gonna run the other one and hopefully it should die. It should die soon. So we're gonna use the tiny autoencoder now. The only difference is. Oh, you know what? I can. Okay, that's fine. I'll paste here. So the only difference, as you can see here, instead of VAE, I'm using a tiny autoencoder. And you see the path to it. That's the only difference. Everything else is the same. Obviously the output file is changed as well. So then I'm going to put enter, and it might be a little bit slower because this guy is not releasing. This guy still hasn't released the RAM and it's a swap space, but it's small enough that it should not be too much affected. So well, oh, I can't kill anything. I should have probably been more. So you can see it goes much faster out of 100. So the irritations per second. Oh, I like that. The GPU temperatures are set to the 31 there. So that's pretty good. Oh, finally, it finally released the. There we go. You see the swap space went smaller, in case you guys can see this. Finally released it because it went smaller, and now it's going big again because I'm doing this in 10 gig here. So you can see how much resources I needed or taken up when it's running this. Okay, so if you remember, it was what, 238, I think it was 238 seconds it took to generate this one VAE guy here, the one using a VAE, the Q4. So we're going to compare it to this one, which is using the tiny autoencoder. So let's see. And remember, it's not a fair test because I started running the tiny autoencoder where, well, that Wan 2.1 model was still, I hadn't released the memory and everything yet. It does eventually do it, but I said I was a little bit impatient because I don't want to wait around. Okay, another little sip of water. It's weird, it smells like bean and rice. Oh, I know what it smells. It smells like jerk chicken. That's what it is. What do you call it? I think they call it peas. There's beans, peas. I was actually thinking of chicken today. Okay, looks like, is it skipping some steps or is it, I don't know what it's doing. Everything is the same except for I swapped out the VAE for TAE, and I said this first run here might be a little bit slower because the other Wan 2.2 model hadn't been released yet, but hopefully that should not slow it down too much, but it should be much faster. Okay, yeah, there we go. You see, it's in 9.53 seconds per iteration, but it doesn't seem to be skipping as many steps. And you can look at the memory and the swap space. So it does use very little, much less. It needs much less resources. 8.7. Wow, that's actually very nice. But wait for it. Once it finishes, look how long the decoding step is going to take. That's the power of the tiny autoencoder. Okay, you see it uses much. The compute buffer is just 6 gigs, right? So that you're already saving on RAM and the other one as well. And it's done. You see this? It's done. It's much significant difference. 208.68. The other one I think was 38 or 48. So you did save. You do save like half a second. And we'll check out the results soon. But I want to run the final. I want to run the final one. This one is running in the background. You can see here it says TAEHV compute buffer. Let's clear this. So this one is the one I'm running now is the Q8 version. What's the temperature? Okay. All right. So when we go here, we can tell the difference. The TAE Q4 and the VAE Q4. So what I'm going to do is I'm going to open up the. This is the VAE Q4 version, and let me know if you guys can see so many artifacts. And then it's the TAE. Right? I don't see any difference. I really don't see any difference. Yeah, so I don't see any difference. Remember, these are both text to images, so I don't see any difference there. So I'll stop both. And this one is now running the Q8 version. And that will be the last run because I said I'm not able to generate. Any Wan 2.2 video. So I was able before. That's why that's the entire reason I came up with this tutorial, because I was able to generate videos before. Thank goodness the Wan 2.1, 1.3b does work, and that one is should work on your devices as well if you're watching this. All right. It's way too cold, so I doubt I'm gonna do a night stream. Yeah, I think I'll make it up to you guys sometime during the week. Yeah, it's way too cold. So yeah, I'll make it up. I can't remember how long the Q8 VAE took, but I do know this should be much faster. You see the compute buffer here, it took up 9, yeah, it's actually less. I do remember the other one was much bigger, so it took up less RAM, sorry, less VRAM. There's no RAM, this is all running. Yeah, so the steps here, I expect the steps to also be faster because it's using obviously the cache, so you should skip some steps as well. And the VAE, sorry, the tiny auto encoder should be much faster. Oh, you know what? You know, it'd be perfect for a night stream. I should actually do Conf UI. Just do the exact same thing in Conf UI. That's actually a plan. I'll make it up to you guys. Some people have requested I do LTX2. That's gonna be fun. That one I checked out, the models are way too big, so I was hoping it would at least fit in the GPU. They don't, so I'll definitely need some RAM. So I don't know how I'll be able to figure that one out. I'll probably have to get a very small, maybe like a Q3 or Q4, and then probably make the image very low resolution and then upscale it later. I think that's the only way I'll be able to get that to run in, say, under 10 minutes. Okay, looks like it's skipping some steps, which is great. Alright, I'm checking. Everything is going well. Let's see. Okay, so it's perfect. Everything is showing up. Yeah, that's what I want. Okay, it skipped about another 3 steps, jumped from 15 to 18. So that's basically what the tiny autoencoder does, is that obviously it has, I don't want to say algorithm, but obviously it's much smaller than the standard VAE, and it does make some assumptions, so sometimes obviously it's going to be a little bit off, or way off, but for quality wise, as you can see, I haven't noticed a difference so far. And I said even when I ran the Wan 2.1 14B, I didn't notice a difference. So it's done. You can see, look how much the compute buffer is. It's less than 6 gigs, so that's great. And we should get our results pretty soon because it's only a 2-step process, and because I think of the timing bar is done. See, 23310. I can pretty much almost guarantee that that's way smaller than what the standard VAE did. So I'm going to turn down to 2 so it's not so loud, and we'll do a comparison. So this is the Q8, and I already know what the other one looks like. Where is the, yeah, so this was the original V8. I mean V8, Q8, sorry. Okay, and then we're gonna get the Q, here we go. Use the same cat. You see the difference? Yeah, I think I like the tiny encoder one as well. So that's it. Both, see, this is the TAE and this is the VAE. So you decide which one you want. All right. I don't need this anymore, so I'm going to minimize you. Let's finish up this tutorial. If you want to take your skills further, I have books and courses on Amazon. The link is also in the description, where you can search for Adobe Ojambo. I have courses on ojamboshop.com. The link is also in the description. And if you want one-on-one tutorials, you can contact me at ojamboservices.com for consultations, or ojambo.com/contact for one-on-one online tutorials. And then I also have some recommended resources. My first novelette is The Algorithmic Serpent. It's by me, Fedora Linux there. It's about an AI scientist who creates an AI system and loses his mind, so he has to regain control of his mind and the AI system. This is the back. This is the paperback version. I'll talk about the ebook version in a second. This is a psychological thriller. Pick it up if it means. It's mostly at cost. I have the Recession Business Blueprint. That's my latest, greatest one. It's a guide to help you start a business during a recession. Right now we're in a recession. That's the best time to start a business. So whether you're looking for budgeting, where to run the business, where to find funds, how to contact suppliers, maybe prospective clients, it's all in your Recession Business Blueprint. There are a lot of tables, there's a lot of text. So you're covered. Every page has at least one table. So you're covered with that. So if you learn the visual way, it's there. If you want the text part, it's there as well. Okay, and this is a blog about me. I'm a software engineer. I'm also an author. My bookshop page on Amazon, my consultation services, ojamboservices.com, and if you're ready to learn, ojamboshop.com for all your online courses. The best way, one way to contact me, you can use a contact form. The contact form says that 14 days after the article goes live. For example, today we talked about AI, we talked about stable diffusion C++. We talked about Wan 2.1, Wan 2.2, so all those are legitimate, perfect topics to write about in the comments. But the best way to contact me is to use the contact form, ojambo.com/contact, ojamboshop.com/contact, and ojamboservices.com/contact. You can follow me on this channel as Odyssey, Rumble, BitChute, YouTube, Kick, and Twitch. Okay, now I am going to again implore you to subscribe, like, follow, and leave comments, because the more people subscribe, the more the content gets pushed out to more viewers. Those viewers join this growing community. They post their tips and tricks, or they can post requests, which I'll review personally, and then I'll share with everyone. I'd like to thank everybody who subscribed so far this month. We're again breaking a record for this channel, or channels. Thank you very much, including the podcast. Hi to the Tech Rants. I do have, I said at least two times a week, there will be just a talk, so more podcast friendly. So I got you guys covered as well. All right, now I'm going to show the outro, and then I'm going to scroll back up, and then just let you know that if you want to see what's upcoming, go to ojambo.com, watch many live summary. You can see we'll just finish this one, accelerating WAN models using the tiny autoencoder and custom encoders. Next up is the Kanama multi-game game server. I'm going to attempt to install it on the Raspberry Pi 0W. After that, I'm going to show you a beginner-friendly game development using Godot 4.61, 4.62, and then after that, I'll show you how to run your access your desktop anywhere using Apache Guacamole, and after that, I'll show you how you can automate rigging using Blender Python API. Okay, so that is it. Yeah, that's it, and I think there was nothing to check in the live chat, so I'm going to end this now, and I'll see you guys tomorrow at 2 p.m. Eastern. Bye.